All right, hi. Our focus for the next 3 days is going to be naming angles and solving equations to find unknown angle measures. So before we can solve equations to find unknown angle measures, we have to talk about what these different types mean. So I'm hoping that you were in class and this has already been done, but just in case, or if you were absent, I'm going to go through these. Remember, a right angle has 90 degrees, and it forms an angle that the two lines meet perpendicularly. So right angle has 90 degrees. Complementary angles are angles that add to 90 degrees. I'm going to be using the symbol like this or like this for angles. So angles that add to 90 degrees. So generally they are right next to each other like this. So this is a right angle and there's two of them to add to 90 degrees. Supplementary angles are angles that add to 180 degrees. So 180 degrees is a straight line. So if we have two angles right next to each other and they have a total sum of 180 degrees, they form that straight line, they're supplementary angles. Adjacent angles. Adjacent angles are just right next to each other. They're next door, right next to each other. They share a common ray. So if we have an angle, here's my common ray. So here is one of my adjacent angles, here's the other. They share this common ray. So they have one of their sides or one of their rays in common. Vertical angles. Vertical angles have, if two lines intersect, it forms two pair of vertical angles. Oops, now I'm doing this in the picture. I'll redraw that over in the picture. So what we know about vertical angles, they are across from one another. They are congruent, so they have the same angle measure, so they're congruent. And by across from one another, again, if you have two perpendicular lines, if they're not adjacent but directly across from one another, they are vertical. So there's actually two pair for every given set of intersecting lines. And again, the idea that they're congruent, they're the same measure, extremely important. Angles on a line. Angles on a line are very similar to supplementary angles. Angles on a line add to 180 degrees because a line is 180 degrees because it's half of a circle. And it does not just mean just two of them, like with supplementary, it could be many of them. So all of these angle measures added together equal 180. And if you put two of them together, you get angles at a point. Angles at a point add to 360 degrees because a circle is 360 degrees. So if you have a whole bunch of angles, all of these angle measures add to 360. So what you're going to be doing is determining the relationship between the angles in a given picture and then deciding do they add to 180? Do they add to 180? 360? Are they congruent? Do they add to 90 degrees? What do we know about them? And you're going to be writing equations and solving. So before that, I also want to talk to you about naming angles, because there are different ways for any given angle that it might be named. So the one that I like the most is figure 2. It's named by a point, or the vertex. So the vertex is named A, so this figure would have angle A as its name. Sometimes it's named by unknown degree, or we can name it by its degrees. So this would be angle B degrees. And lastly, and the one I like the least because it's the most time consuming, is by the 3 points. And the reason we use 3 points is for complicated pictures like this one down here. If we just said the end point, E, that vertex point, like we could here, which angle are we talking about? Are we talking here or here? Which angle? So we have to specify using 3 points. And it's important for you to remember that this middle one, that vertex point, goes in the middle. So this would be angle CAD or angle DAC. So to save time, I'm not going to name all of the angles. I'm just going to choose one angle, but I'm going to more show you, and then I want you to fill this out on your own. So if you're just watching this video and not filling anything out, I will try to go slow, but I still want you to pause and write in the angles. And remember, we're going to name them by their endpoints, the 3 points that make up the angle. So first we have to find two angles that are vertical. So we're going to come over here, and I'm going to just find 2 lines that intersect. 2 lines, so not line segments, 2 lines. So I'll do this one. So if I have this line, it's kind of dark, it intersects with this line. So I could name this and this as one set of one set of vertical angles. And so to name them, remember we use the endpoints. So we have A and E and C. So angle AEC is vertical and congruent. This little symbol here means congruent. It means they're the same angle measure as, I'm going to erase this, I hope, so I can see. Well, I think that's a B. So angle BED. We could have also named this angle and this angle as vertical angles. All right, from now on what I want to do is just show you instead of taking the time to write it out, but I want you to write it out. So I'm going to point out different adjacent angles, and then I want you to choose just one of them. So anything that shares an side are adjacent. So this angle right here, AEC, would be adjacent to angle CAD. F. CAF would also be adjacent with BED. And BED would also be with this one right here. So anytime they share sides, they're adjacent. Okay, so adjacent. So any of them, now let me go over it with just the light. So this angle is adjacent with this angle. This angle is also adjacent with this angle. This angle is also adjacent with this angle, as long as they're just right next door. So name two angles that share that common ray. All right, let's complete some practice problems. So here it says, in a complete sentence, describe the relationship in the diagram. They are adjacent, but that doesn't really help us with the angle measure. I see that they're on a straight line, so they are supplementary. But you could have also said, and they are angles on a point, so add to 180 degrees. So now we know that the sum of this angle measure plus this angle measure equals 180. So this is a really easy equation to write. X plus 132 equals 180. And then we can solve that equation. It's plus 32, so we're going to subtract 32. So X is going to be 48. So angle CAB is 48 degrees, because 48 plus 132 equals our straight line of 180. All right, another example. Here, what we can say is all the measures shown, so angle BAC, CAD, and DAE are angles on a line. So again, in a complete sentence, that's what you should be saying, that angles BAC, CAD, and DAE are angles on a line, therefore add to 180 degrees. So they're angles on a line. And I am shortening this. You should be naming the angles on a line. So add to 180 degrees. So now we can write our equation. We have 3x plus, and this is a right angle, so I know that it's 90 degrees, plus 2x equals our 180 degrees. And now it's simply solving that equation. So if you really did a nice job and are good at solving equations, this should be a piece of cake. The first thing we have to do are combine like terms. So 3x plus 2x is 5x plus 90 equals 180. So we have to subtract 90. So 5x equals 90. And we're going to divide by 5. Going to divide by 5, and feel free to use a calculator or just paper pencil, or in this case stylus and iPad. And it comes out to so x is 18. But then it wants the measurements of these two angles. So BAC was 5 times 18, and angle DAB, E, was 2 times 18. So once you figure that out, and again use a calculator or do mental math, 5 times 10 is 50, 5 times oh, it's a 3, not a 5. Sorry, guys. I'm like, that doesn't work out. Okay, so 30 plus 24, this is 54, and 2 times 18 is 36. So if you do 50 plus 36 plus 90, that equals 180. So again, for the sake of time, I'm going to quicken this up a little bit. So you should be writing down the complete answers, but I'm just going to be saying it out loud. The first thing it says is describe the relationship. Well, I can see that if I'm trying to figure out x first, if I'm trying to figure out x, then my known is the 144. So these form that straight line, and since they form a straight line, I know that x plus 144 equals 180, and then I can solve to find out what x is. So I have x on this side, and I have 44, all right, so 36. So if we add up the 36, and I always like to double check, especially when I'm using a stylus and it gets messy. Does that really add to 180? So it does. So please check your work. So I've got 180. So now I know that x, this angle right here, is 36 degrees. But what about my I? So I could do this by noticing that this part right here, these two angles, form a line. So I could subtract 360 by 180. So it's kind of going backwards from here. But mostly I like to use the easy ones without any subtraction. These two angles are vertical angles. So remember, be talking about this, because remember, part of it is naming the angles. So y is vertical from the 144, so y must equal 144, because vertical angles are adjacent. So y is 144 and x is 36. All right, next, write an equation for the angle measurement, for the angle relationship shown in the figure, and solve for x and y. So again, I'm going to write that equation. I'm going to skip the describing the angle. Well, we're going to talk about it, but you should write this down. So we're going to go back over here. I'm going to blow this up. So what I know is this. I know that these two angles are vertical. And since they're vertical angles, I know that this 85 degrees is congruent to this. So I know that these two angles are equal. So these two added together, the sum of that is 85. So now I can do 3x plus the 16 equals 85, and I can solve that equation. So 3x equals, oh my goodness, 989 divided by 3 oops, sorry, that's 69, divided by 3, so x should equal 23. Now how I like to check it is I would do 2 times 23, so I'd be working backwards. So this is 46. Oh, sorry. And I'm not going to go back, I'm just going to redo. So 23 times 3 is 9 and 6. Oh my goodness. Clearly I can't do it here either. So 69 plus 16 gives us our 85. Okay, hopefully that's enough. I will try to make the next video to show you more examples. We out.